So this is the third part of our little lesson on solving quadratic equations through factorizing. So we started off with looking at common factors and difference of two squares and a little bit about trinomial factorizing. So I want to just finish off with a little bit more and the more complicated trinomial factorizing. So have a look at this. We'll solve these quadratic equations. Difference with this one is that the squared term is a negative, and that can be a wee bit tricky for factorizing. It can be factorized as it is, but if you think about a wee bit of algebraic skills, if we multiply every term in the equation by -1, if we multiply everything by -1, crucially on both sides, we're allowed to do that, then think what we get. We get -1 times 3 is -3. -1 times -2a becomes +2a, and -a squared times -1 becomes plus a squared. In other words, all the signs just flip around, and 0 times -1 is still 0. That allows me to shuffle the first and the last terms around, and I get a squared plus 2a minus 3 equals 0. For most people, they prefer to have the letter term at the start. You can do it by inspection once you get good at it, by just flipping all the signs in your head as you rearrange it, but if you want to do it that way, that's fine too. What we're left with is a quadratic expression. We have to do trinomial factorizing, just like we did with the last video. So we've got a and a in the first two terms. Because it's just 1a squared, we can use the kind of mental method of saying factors of -3. Well, that's just going to be 1 and 3. They've got to add to +2. What do we do with a minus sign? We're going to stick it in front of the 1, aren't we? Because -1 plus 3 is +2. So the first number is -1 and the second number is +3. And that takes us to, hopefully now, if you've watched the other two, very quickly we can say that if two numbers multiply to 0, either the first one has to be 0 or the second one equals 0. So solve the two equations, a equals 1 or a equals -3, and we can write down solution a equals -3 or a equals 1. You do the same for the green one, and if you want to pause the video because I'm about to go over it, so try it yourself first of all and see if you agree with me. Okay, so if we, by inspection, we can say that -p squared becomes +p squared, plus 3p becomes -3p, and plus 4p becomes -4. Hopefully you see the idea of, if you like to still multiply it formally and rearrange it, that's fine, but this is another way of doing it. We can factorize it by saying p squared splits into p and p. I've got two numbers that multiply together to give me -4 factors of -4. That's going to be 1 and 4 or 2 and 2. And we want the answer to be -3. So I've got a minus sign to put in, so the answer is -3. Where would that go? The bigger, it would have to be +1 minus 4 is -3, +1 and -4. So we can say either p plus 1 equals 0 or p minus 4 equals 0. Therefore, p equals -1 or p equals +4. So the solutions are p equals -1 and p equals 4. Okay, hopefully you got that. If you did, then well done. We're getting there. So let's have a look at just these slightly different ones. They don't look like quadratic equations. Have you noticed, and I haven't really made a big deal of it yet, have you noticed that all our equations are equal to 0? Have you asked yourself yet, why are they always equal to 0? Well, it's because of the whole business of if it wasn't equal to 0, we couldn't ask ourselves what are the values of a or b. Okay, because if you think about it, if I think of two numbers and I tell you that they multiply together and the answer is 2, well, there could be an infinite number of possibilities. Okay, A could be 4 and B could be a half. A could be 2 and B could be 1. that A could be a quarter and B could be 8. Yeah, it goes on and on. So the only way in which we can logically kind of come up with splitting it up is if we make sure our answer is 0. So that's why we're dealing with this. So if you get a quadratic equation that doesn't equal 0, then all you need to do first of all is use a little bit of algebra to rearrange it so that it does. That's all. It's got to be equal to 0. So in other words, I need to take 16 away from that right hand side. I need to take 16 away from the left, so I end up with t squared plus 6t minus 16 equals 0. Okay, and from then on we're back to our quadratic factors. So that's t and t. Factors of negative 16, when the bigger the number, the more factors there are and the trickier it can be, so just be careful. Sometimes it helps to write them all down. I'm only doing that, I don't normally do it myself, but I'm doing it just in case it helps you think of a different way. So we need to put a negative sign in front of one of those, and the answer's got to be positive 6. So where does it go? Negative sign in front of one of them, well, it's going to be the 2 and the 8. Negative 2 plus 8 is positive 6, so t minus 2 and t plus 8. So here we go, either t minus 2 equals 0 or t plus 8 equals 0. So t equals positive 2, t equals negative 8, and our solution, see I'm rushing it now because I'm so familiar with it, but I should take my time. Solutions t equals negative 8 or t equals positive 2. And remember, what does that mean? It means that if I put either of these things into the original equation, if negative 8 squared plus 6 lots of negative 8 will give me the answer 16. Or 2 squared plus 6 lots of 2 will give me the answer 16. There's only 2 possible values that will give us that. Okay, you try the green one. N squared equals 4n minus 4. Pause the video if you want to try it yourself, because I'm about to go over it. Okay, let's do it. This time there's 2 terms on the right hand side, so effectively I have to subtract both sides by 4n, and I have to add 4 to both sides, so we end up with n squared minus 4n add 4 equals 0. Okay, if I factorize that, I've got n at the beginning of each of my numbers, and I want factors of positive 4. Okay, factors of 4, which could be 1 and 4 or 2 and 2, and they have to add up to negative 4. Well, hang on, okay. Well, that means that if they add to negative 4, remember that factors of a positive number means that both could be negative. So it's, either negative 1 and negative 4 or negative 2 and negative 2. Luckily enough, negative 2 and negative 2 give us negative 4, so we've got negative 2 here and negative 2 there. Now that throws up something that hasn't happened before. Okay, so either, well, hang on, either n minus 2 equals 0 or n minus 2 equals 0. So n equals 2 or n equals 2, we've only got one answer. There technically are 2 answers, but they happen to be the same. So we can say, of course, that the solution is just n equals 2. So sometimes there is just one answer to a quadratic equation, because the same answer is repeated both times, and we just think of that as one answer. So there's an interesting little twist. We'll be talking about that later on. Okay, and last one here. Oh no, here we go. This is the biggie, of course, because for some of you factorizing trinomials with a non-unitary term adds a little bit of complication, so I'm just going to quickly go over that. I'm sticking with prime numbers at the beginning, just so that we're not here all day. So let's just have a look at this. I want to factorize 2x squared plus 7x plus 3. If there is a number at the beginning, make sure that there isn't a common factor that could be taken out, and that would make it much easier. Okay, in this case there's not. So what I want to do is I'm going to put my pair of brackets there. I know it's going to be 2 terms. And I know that I can split 2x squared up into 2x and x. There's only one possible combination of terms that make it 2x squared. So that's fine. But what happens with the this plus 3 and plus 7. I can't just do factors of 3 that add to 7. So you'll have a system in place again. You might have a mental system that works by trial and error, which is absolutely fine. My system that I usually recommend is, once you know your starting terms, put them in here in a wee table, 2x and 1x, and you're going to start listing above each other factors of positive 3. So it could be kind of 1 and 3, or it could be 3 and 1. And the way in which we work out which is that you multiply diagonally, multiply across from top to bottom. So 2x multiplied by 3 gives you 6x, write it down underneath, and x times 1 is 1x. And if you add those two together, you should get, that's positive 7x, you should get the number in front of the x term there. And if that doesn't work, you score them out and you try the next possible combination. I've managed to get it first time. So what we do, remember, is we don't use the pair that have multiplied. We actually use the pair that are on the same level. Okay, so it's 2x and positive 1, and we've got x and positive 3, and so we've got that. And what this throws up, same idea, two numbers multiplied together to give a 0, either 2x plus 1 equals 0, or x plus 3 equals 0. And this will be the first time that we're going to end up with a fractional answer because of this multiplier. So we can take 1 away from both sides to say that 2x is negative 1, half both numbers, we end up with x equals negative a half. For the other one, x equals negative 3. So our solutions in this case are x equals negative a half and x equals negative 3. Okay, so check the green one out. 3x squared plus 5x plus 2 equals 0. Pause the video if you want to try and do it yourself, because I am about to go over the answer. Just keep that up. Okay, there's no common factor, so we can't do that, unfortunately. So we can make a pair of brackets. We could decide what goes at the beginning. 3 is prime, so it can only be 3 and 1, and we've got an x and an x. And so therefore, I'm going down here, I'm just going to put 3x and 1x, and then I've got positive 2 as my number at the end. So I'm going to think about factors of, I've kept them positive just now. Okay, we'll do it one more, which is negative. So what have we got there? We multiply 3x times 1 is 3x, and x times 2 is 2x. Oh, hang on, they add together to give me positive 5x, and that's what I was looking for. So the numbers are 3x and 2, and x and positive 1. 3x and positive 2, and x and positive 1. So you should have then said either 3x plus 2 equals 0, or x plus 1 equals 0. So x is negative 2/3, or x equals negative 1. So my solutions are x equals negative 2/3, or x equals negative 1. I didn't get them in order, but I'm not going to bother about it. So there we go. Well done if you got them. Okay, last one we're going for, and is, I've mixed them up because, of course, negative x squared terms, and I've got a number in front. So these are the top ones to solve. I'm going to use what we learnt at the beginning of this lesson by flipping the signs, multiplying everything by negative 1 and rearranging it because it suits my purpose. Okay, so all of the terms, I've got the opposite sign in front of them, and I've rearranged it at the same time. Great. I know that I can't take a common factor of 3, so I'm going to have to use this method of factorizing. 3x and x go in the front, and if I draw my wee table, then we can say that we've got 3. Now there's negative signs in here this time, so that's going to complicate matters. Negative 6, so I need factors of negative 6. It could be 1 and 6. Like that. Now one of them's got to be negative, so I'll put negative 6 here. And it could be, now the problem is that there's all sorts of combinations, even just of of 1 and 6, and then I've got 2 and 3 to do. So it could take me a wee while if you just try all the different combinations. Hopefully you can see that, let's just try it here, and we'll go through it. 3x times negative 6 is negative 18x, and add 1. Now, see when you change the signs around, that's negative 17x. That doesn't work. And if you just change the signs around, it's just going to give you positive 17. So you basically get a doubler for that. Check the next lot. 3x times negative 1 is negative 3x. And x times 6 is positive 6x. Add them together, you get positive 3x. That's not what we're looking for. We're looking for negative. Well, no, we're looking for positive 7. Watch that. I've changed it. So they don't work. So I have to actually think of another pair of factors that's not 1 and 6. So that's going to be 2 and 3. So again, there's a couple of possible solutions. It could be 2 could be here, and 3 could be here, or the other way around. So let's have a look at, say, one of them's got to be negative. So let's put negative 2. 3 times 3x is 9x, and x times negative 2 is negative 2x. Add them together, you get positive 7x. Good, we've got it. So it's 3x minus 2 and x plus 3. So we can say either 3x minus 2 equals 0 or x plus 3 equals 0. Solve it. 3x equals 2, x equals 2/3, or here x equals negative 3. And you can see why now that I like to put the answers together, because they're a wee bit far away. So x equals negative 3 or x equals 2/3. There's my answer. Okay, so you try, this is the last one on the green. 10 minus x minus 2x squared. Pause it if you want to do it yourself, because I'll quickly go over the answer. Just going to use this table again. Okay, let's try it. I'm rearranging it by multiplying everything by negative 1. Positive 2x squared plus x minus 10 equals 0. Factors 2x and x. So 2x and x, we're looking for factors of negative 10. Now, clue, it could be 1 and 10 or 10 and 1. But we're going to start then making big numbers. And clearly the difference is only 1. We want plus x there, plus 1. So I'm going to jump straight to 2 and 5, okay? I can go back to 1 and 10 if it doesn't work, but my hunch is that it's 2 and 5 somewhere along the line. So 2x times 5 is 10x, and x times 2 is 2x. No, that's 12x, too far away. Let's swap them around. But of course, one of them's got to be, I'm forgetting, one of them's got to be negative. Okay, so let me just check. If one of them's negative, x times, okay, so let me start again. I was rushing there. We're putting 2 and 5. As I said, let's make 2 negative. So x times negative 2 is negative 2x, and 2 5s are 10x. That's going to give me 8x. I know if I flip the sign to the 5, it's just going to give me negative 8x instead. That's not what I'm looking for. So let's put the 5 and the 2 the other way round. I'm not even going to put the sign. Watch. 2x times 2 is 4x. And x times 5 is 5x. Oh, I want to make positive 1, so I want the 4 to be negative. Okay, that means that 2 is going to be negative. I could work back. Okay, so I've found out that in actual fact I get positive 1x by making 5 and negative 2. So 2x plus 5 and x minus 2. We get either 2x plus 5 equals 0 or x minus 2 equals 0. So that gives us 2x equals negative 5, x equals negative 5 over 2. And our solution, hopefully you've written that down, is x equals negative 5 over 2, or x equals 2. So well done if you've stayed with me through that. Hopefully you've got some good techniques now about how to solve quadratic equations over all of this, and that will help you in your study of quadratic functions. Okay, hope that's been helpful. On you go.